Assalamualaikum warahmatullahi wabarakatuh. My name is Adam Airil bin Muhammad Yusof. My metric number is M0325100031 and I am a Master by Research student from FTMK. So today I would like to present my research proposal on the title of a data-centric framework quantifying image quality tipping points in agricultural plant disease classifications. So in today's presentation, I would like to talk about the research background, the methodology, the expected outcomes, the motivation for this research, and the timeline. So for the research background, this research has addressed three kind of research problems, which is the first one is the literature lack of an empirical tipping point of plant disease classification accuracy against the significant environmental factors that degrade the image quality, which causes misclassification. The healthy plants labeled as disease plants and the disease plants labeled as healthy plants. That is misclassifications. The second problem is the current image quality assessment is often used for isolated environmental image corruptions, meanwhile in the simultaneously. So the last problem is the existing image quality measurement metrics show inconsistent results across different network architectures. So the same measurement metrics used on the different architectures show different results, so it is inconsistent. So that's why this research will solve this problem with the three objectives that it want to achieve. The first objective is to identify the tipping point where plant disease classifier accuracy declines non-linearly under control image degradation levels across different CNN architectures. So in this illustration here, the model accuracy will drop at the certain severity level. So this is the tipping point that this research want to identify. The second one is to develop a dataset quality index, DQI, using no-reference IQA, blur and noise quality measurements combined with an objective weighting method as shown in this illustration. And the last RO, this research want to evaluate the relationship between DQI scores and plant disease classifier accuracy across multiple CNN architectures using Pearson and Spearman correlation analysis, so that the DQI formulated in this research used on different CNN architectures will result similar result. So in this research, there are 5 main stages in this research, which is the first one, data preparation, followed by model training, model testing, model field validation, and statistical analysis. So dive deeper into each stage. The first one is data preparation. This research will use two kind of dataset. The first one is Plant Village. It is a curated lab dataset. The second one is Plant Doc. It is a real in the wild dataset. So both of these datasets have been downloaded and stored inside the Kaggle notebook database. The second stage is model training. So in this research, there are 3 CNN models that will be used, which is the first one is ResNet 5.0, MobileNet v2, and EfficientNet v0. So all these models will be trained using the 70% of clean Plant Village dataset and will be validated using the 15% of unseen Plant Village dataset. So after the model has been trained, it will be tested using the degraded images of the Plant Village. So 50% of Plant Village will be injected with the blur noise parameters. Then the model will be tested using that degraded images, and the matrix will be computed and stored inside the database right away. So this is a loop phase because it has 121 blur noise combined severity. So in each loop, it will be degraded by one level of blur and one level of noise. There are 11 severity level of blur and 11 severity level of noise, yielded to 121 blur noise combined severity, and it will be 121 loops. So it is a loop phase and it uses streamlined degraded testing (SDT) pipeline, so that the RAM storage will be flushed after each loop is done to avoid the bottleneck of computational network. The fourth stage is the model fit validation. The model have been trained and tested using the curated laboratory dataset Plan Village. Now it will be validated its generalizability using the PlanDoc dataset. Because the PlanDoc assume it has a natural blur noise effect, so the images are not being injected with any synthetic noise and blur parameters. So after the model has been validated, the matrix will be computed right away and stored inside the database. So the metric that has been computed is accuracy and a DQI value. And last but not least, the statistical analysis stage. The stored matrix will be used to plot two types of graph, which is the first one is line graph. It maps the model accuracy against the severity level to identify the tipping point. The second graph is scatter plot. It maps the model accuracy against the DQI value to validate the formulation of DQI. So if the graph shows a strong positive correlation, like this graph, so it means that the DQI formulation is a success. So this is how the ROs being mapped in the methodology, which is the first RO want to identify the tipping point, the second RO want to develop the DQI, and the last RO want to evaluate the DQI. So there are three expected outcomes in this research, which is the first one is identify tipping points. So it will be the cutoff guidance for the CNN model as known as the plant disease classifier. So imagine a plant disease classifier using a CNN model. It will capture an image of plant and it will be signaled using three cases. The first one is good signal. It is because the model accuracy is still high, so the image is in high quality. The second one, the model will be signaled as caution, because the model accuracy is begins to drop significantly, but we can use the image but with caution. And the last one, the image need to be recaptured because the model accuracy has been dropped because it is severely affected by the blur and noise. The second one is the formulated DQI. So the data quality index will be the guidance for the farmer to capture reliable image for plant classification tasks. So same as before, there are three cases. The first one, we can see clearly the details of the leaf. So the DQI shows a high value and we can use the image for the classification task. The second one, the image affected mildly with the blur and noise parameters. So the DQI is lower than before, so we can use the image but with caution. And the last one, we barely see the details of the leaf, so the DQI shows a very low value and the farmer need to recapture the image of the plant. The last expected outcomes is the DQI correlation result. So it will provide a list of CNN models that have been proven to optimize the plant disease classification task. So for this research, there are three CNN models or architectures that have been trained and tested, which is ResNet, MobileNet, and EfficientNet. So if the research is a success, so the farmer can use these three CNN architectures in their plant disease classifier model. There are four motivations that I have to conduct this kind of research, which is the first one is national policy alignment. This study complies with the National Agro-Food Policy, the NAP 2.0, by leveraging 4IR technology to reduce crop loss and prevent system misclassifications. The second motivation is the SDG 9, Innovation and Infrastructure. This research intends to upgrade precision agri-tech infrastructure by embedding a digital quality control mechanism directly into edge device classification models. The third motivation is SDG 12, responsible production. This study wants to minimize post-harvest waste and chemical overuse by preventing inaccurate diagnostic decisions caused by corrupted image inputs. And the last motivation is personally my personal motivation. I would like to protect household consumers from purchasing damaged or rotten organic produce at supermarkets to ensure the stability and reliability of grocery spending. And for the timeline, this is my timeline. I am in the middle of the second semester, July 26th. So I have done the 3 chapters of thesis writing, and I have done my research proposal defense last month and passed with minor correction. And now I am in the first stage of my research experiment activity, and I hope the rest of the research activity will be done and conducted smoothly until the Viva Voce session. So that's all from me. Thank you for your attention.